Sorry, by mistakenly I saved the audio and cut the video. So actually this would be positive because the current flowing through this loop is in the opposite direction in which we are tracing the loop. That's why it would be positive. So it would be VAB would actually be equal to 3I1 minus 3I1, you take it plus 3I1 plus 8 minus 3I2. So basically I just multiplied it by minus 1, so this becomes negative and both of these become positive. It becomes 1 second, 3 into 1.25 plus 8 minus 15 it's 3.25 volts. The answer could be negative or positive, but you have to consider it positive every time. So now we are considering this sum for Thevenin. We actually have to find the voltage across the 2 ohm resistor. We have to find the current through the 2 ohm resistor. We have to solve this by Thevenin. So in order to solve it, we first need to calculate VTH, which is the toughest part. So 1 second. We need to calculate VTH, which is the toughest part. So we need to take this branch open first, like 40 volts, 20 volts, 10 ohms, and taking this 2 ohm branch open, then it becomes AB VTH. It becomes this way. So now, just like we did in the previous sum, we need to calculate the potential difference through A between A and B. So in order to do that, we need to find out the potential drop through this and through this. So in Thevenin, so first we'll consider this loop. So it's 5. So we'll consider this loop. Therefore the current flowing through it would be I is equal to 40 minus 20, that is 20 volts upon 5 and 10, that is 15, if I'm not wrong. Let me take the loop. Suppose if you go from here, it may do this. That is, actually I'm considering it this way. That is 15 upon 20. 20 divided by 15. 1.33 amps. So now to find the VTH is equal to the potential drop through this resistor and the potential drop with this. This is 10 volts and this is 10 ohms. So these both would add, because in Thevenin, if this is positive and this is negative, and if the negative part hits the positive part of the battery, then we consider the battery when we add the battery to the resistor. So in the loop, if it would have been vice versa, like if this was a negative, if this was the positive part and this is the negative part of the resistor, then we would have to subtract the potential difference through this and then the potential difference to this. But right now it's negative and this one is positive. So VTH is the potential swap to this, that is 10I plus 10 volts which is 23.3 volts. The sum is there in Ravi's thing. You can check it there. RTH is pretty easy to find, and after finding the RTH you have to simply RTH is pretty easy to find. This short circuit all the voltage source, and this is 5 ohms and this is 10 ohms. These two are in parallel, so it becomes 50 upon 15, which is 1 second, 50 divided by 15, 3.33 ohms. So now we have to put 3.33 ohms, 3.33 ohms in series to the 23.3 volts which we got as VTH, 23.3, and this has 3.35. Is my phone getting hot? Okay. And this as the 2 ohm resistor. And now to calculate the current through the 2 ohm resistor, we use the simple formula 23.3 upon 3.3 plus 2 is equal to 23.3 divided by 5.33. It's 4.37 amps. I'm right. Yes, it's 4.38 in the Ravi set. It's 4.37 we are getting. We'll solve this one. So now we are taking a second type of sum. Basically in this type, in the previous sum, the 2 ohms was directly connected parallel to the 10 ohms. That's why we could directly take this into the loop and find out the potential drop. But here it's not considered, it is not 8. We have to find voltage across through 8 ohms, and it is not directly current across 8 ohms by Thevenin, and it is not directly connected to 5 ohms in parallel. Therefore because of this 10 ohm resistor, so we have to take the loop as this entire loop. We have to take in consideration this entire loop, and this 5 ohm branch is actually redundant in this type of function because it is directly parallel to the 75 volt power supply here, whereas in the previous sum there was a 2 ohm power supply in between the 10 volt supply, between the 10 volts. That's why you couldn't make 10 ohms of redundant branch, whereas here 5 ohm, this 5 ohm is a redundant branch if we take in consideration the entire circuit. So we'll take this as the open branch. Now when this branch becomes open, 5 ohms is not actually redundant because 75 volts is meaningless as this loop goes open. So only this loop is in consideration, and it's not directly parallel to this, so we have to consider the 5 ohms here in this loop. B. So the current through it would be 25, will be 10 upon 20. The current I is equal to 25 amps by normal formula V is equal to IR. So we got the I which is flowing through here. So now we'll calculate the VTH simply. VTH is equal to so this is the positive part, this is the negative part. Positive part is hitting the positive part of 250 volts, and the negative part is hitting the negative part of 75 volts. So as we have done before, we'll take this positive 5i1, we'll take this negative 250, and we'll take this as positive 75, which becomes 525 125 plus 75 minus 250 is equal to um, and bad at calculations, it's 50 volts, and in Ravi Singh it's 50 volts, so the answer is matching. You can calculate the RTH easily, so I'm skipping that part. So now in this sum we need to there would be two loops while finding VTH, that is actually calculating I to find the VTH. So we have to find the voltage current through 2 ohms. So in order to that, we always take it open as we do, then it's a bit rough as 3 ohms, this is 112 and 2 ohms. We need to find the VTH, that is A to B, from here. So now we actually need the current through 3 ohms, only 3 ohms, by taking this as the loop, that is A to B. It's actually confusing, why can't we take this loop or this loop? It's on my suggestion, you should always take the loop which has the 4 volts which has the power supply attached to it and which is smaller. So we can't take this entire loop, just take this loop, it's smaller and it also has a source supply to it. So always take the loop which has a supply to it, not just a resistor connected to it. So we are taking this loop instead of this to find the VTH, but first we need to calculate I as we have done before. So in order to calculate I, we take these two loops, this one and this one, so I1 and I2, so it's 2 plus 2I1 plus 12 I1 plus 12 I2 is equal to 0, therefore it becomes 14 I1 plus 12 I2 is equal to 0. So I've done that. We have taken second loop, sorry, spaced out. 3 ohms, 4I1, 4I2, 4I2 plus, that is 16I2 plus 12I1 is equal to 4, minus 4 is equal to minus 2. So I will solve that. 1 second, I'll see. Equation, it's getting dark. I need to switch on the lights. Okay, wait a minute. 2 unknowns. So it's 14, okay, 12, okay, minus 2, okay, 6, no, it's 12, okay, 16, okay, and minus 4. So I1 is equal to 0.2 amps and I2 is equal to minus 0.4 amps. So this is 0.4 amps in the opposite direction because it's negative. We got the answer negative, so that's in this direction. So this is positive and this is negative, and negative hitting the positive, so we have to add these both to get the VTH. So we get the VTH as 1.2 plus 4 is equal to 5.2 volts. Hopefully it's right. Second, 5.2, or you can, sorry, I took the, this is negative and this is positive. So basically the positive side is facing the supply, the point which is facing the supply is called the positive side. So I actually mistaken in the annotations, which is where you could go wrong. It's 2.8 volts. So there was a mistake in the last one, it shouldn't happen, but took the sign wrong, unfortunately, but it's right now. So yeah, so these are actually the three sums which could from which you could understand the entire thevenin. And obviously first try to solve these types of sums because they are important to understand thevenin. Bye.